Okay, so here we have to find the minimum value of the function fx is equals to 1 by 3 x into x square minus 3 in the interval minus 100 to 100 occurs at the minimum value occurs at which value of x. So first let's check where this function have the stationary point, or you can say where function is changing, so we can calculate the derivative of this. So that would be x square minus 1 and that is equal to 0. So x this function have the stationary point at x equals to plus minus 1, right? And we have to check from this minus 100 to 100. So these are the points that you will have to take consideration, that is minus 100, 100, 1, minus 1. So you will find the value of f of minus 100, f of 100, f of 1 and f of minus 1. So at which you will get the minimum, and the argument of that will be your answer. So you will get the minimum when you will put this to this function. So you will be getting minimum at x is equals to minus 100. So 1 minus 100 is the answer for this question. Okay, so let's look at this question. The range of value of k for which the function, that is k squared minus 4 into x squared plus 6x cube plus 8x to the power 4 has a local maxima at point x equal to 0. So this function has a local maxima at point x equals to 0. What you have to find for what range of the k, right? So what you can do simply, so first of all you will have to find the derivative of this function and then double derivative, and then since this point is the point of maxima, so at double derivative at x equals to 0, that would be less than 0, then you will have the value of k, right? So let's first find the first derivative of k, that will be 2x k square minus 4 plus 18x square plus 32x cube, right? Now find the double derivative. So double derivative would be, that would be 2x k square minus 4 plus 36x plus 96x square. Now you will have so since at x equal to 0, fx has local maxima. So then this f double dash x equals to 0, this would be less than 0, right? So you put at here x equals to 0, so you will get 2 k square minus 4 should be less than 0, and from here k square should be less than 4, that means k will belongs to greater than minus 2 and less than 2. So the correct answer for this is D. So this question is from 2016 ME. Consider the function fx is equals to 2x cube minus 3x square in the domain minus 1 to 2. The global minimum of function fx is. So you will have to find the global minima of this function fx, right? Or within this domain, right? So what we can do, we can find, first of all we can find the stationary points where may function get changed, so that we can find using the first derivative. So and then we will equate to 0, right? And from here what we will get is x is equals to 0 and x is equals to 1, right? Now we have the points, this one, this one, this one, and this one. So let's check it out that uh, at these points. So uh, at f minus 1, at f2, at f0, and f1, right? If you put minus 1 here in fx, you will get minus 2 and minus 3, that is minus 5. And here if you will put 2, then you will be getting 8 minus 6, that is 2. And for 0 it is 0, and for 1 it is minus 1, right? Now max, because we have to find the minima, right? So min, so at what value, for what the minimum of this, so that is minus 5. So at x is equals to minus 1 we have the minimum, right? So the global minima of fx in this range, in this domain, is minus 5. Okay, so this question is from easy 2016. As x varies from minus 1 to 3, which of the following describes the behavior of function fx is equals to x cube minus 3x square plus 1. So we have to check that from minus 1 to 3 the behavior of the function, for what range it is increasing and for what range it is decreasing. For that, first of all, find the points where we can get the information of this function. So obviously we are going to make use of these 2 points. Also we will find the stationary point where function is changing, right? So that will be where we will find the derivative of function, that is equal to 0. So the derivative of function is 3x square minus 6x, that is equals to 0. And from here we will have x is equal to 0, right? And x is equals to 2, right? Now let me just give, so also what you can do, you find the value of the function at all of these points. So let me do that. So f of minus 1 is, so 1 minus 1 minus 3 plus 1, so that is minus 3, right? And f of 0 is 1, and f of 2 is 8 minus 12 plus 1, right? Yes, and here we will have minus 3, right? And f of 3 is also there, right? So that would be 27 minus 27 plus 1, that would be 1, right? So we have the points, that is x is equals to minus 1 and 0, right? And we have 2 and we have 3, and these 2 are the stationary point, 0 and 2, right? So the slope of the function would be 0, right? At each point the slope of the function would be 0. And you see why I have marked that f0 is greater than, so you see that at ff0 and value at ff2, that should be somewhere here, right? So so in this range function is maybe decreasing something like that. What? So it is decreasing, maybe, I don't know. And again for f of 3 it is 1. So 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 maybe something like that. And at f equals to -1 it is -3. So maybe here, right? So you see function is increasing at, you have to check at this range, right? And then decreasing and then increasing again, right? So this statement B is the true one, increasing, decreasing, and then increasing again in this range. So this question is from 2016 IN. We have given this function of domain -1 to 1 and range is some a real number where fx is equal to 2x cube minus x to the power 4 minus 10. The minimum value of fx is, so we have to find the minimum value in this range, right? So what we can do, we can simply first check the stationary point by taking the first derivative and equating it to 0, right? So from here we will find that the stationary points will be x equals to 0 and x is equals to 3 divided by 2, right? And if you see this point 3 divided by 2, that is 1.5, that is out of this domain, right? So we will not consider this, right? Now we have the points, that is -1 and 0. So find the value of f at -1, that will be -2 minus 1 minus 10, so that will be -13, and at f0 it will be -10. So we have to find the minimum value of fx, that is -13. So this question is from EE 2016. The maximum value attained by the function fx is equal to x into x minus 1 into x minus 2 in the interval 1 to 2. So we have to find the maximum value of this function in this domain, right? So we can proceed as usual. What we can do, we can find the first derivative and find the stationary point. Then we will look within the domain that which point gives us a maximum value. So let me first multiply this so that it's easy to take the derivative of that. So it will be x squared minus x into x minus 2, that will be x cube minus 3x square, I think so, minus 2x. So here it will be 3x square, right? Let me do it. That will be minus 2x square minus x square and minus plus 2x. Now we can take the first derivative of this, that will be 3x square minus 6x plus 2. We can equate it to 0. From here we can find x, that will be minus b plus minus root over b square minus 4 into a into c 12 गुना 2 24 divided by 2a, that is 6, right? And from here we will have 6 plus minus 36 minus 24, that is 12. So 2 root 3 divided by 6. So here we will have 3 plus minus root 3 divided by 3. I hope I haven't made any mistake. So 1 will be 3 plus 1.73, that is 4.73 divided by 3. So that will be approximately, I think, 1 point something 5 or 6, one value, and one value will be 3 minus root 3. So that will be less than 2, right? So now if you so both the point will be in this interval, I think, right? Okay, so we will have two value. Now we can put this value, that is 1 2, this 1.6 and this I think I will have to use the calculator. So anyhow, I think if we that value will be 1, that is 3 minus 1.73 divided by 2, and if we put this value here, that is going to be negative, right? So we have to find the maximum value, and at 1 it will be 0, at 2 it will be 0, and which point at 1.6 it is going to be negative. Even also this point at it will be negative, so maximum value from this function we will have 0. So this is the answer for this question. So this question is from 1994. The function y is equal to x square plus 250 divided by x at x is equal to 5 attains maximum, minimum, neither 0. So that is what we have to find. So how we can do that? Simply we can check the double derivative. If it is less than 0, then at that point it will attain the maxima, and if it is greater than 0, at that point it will attain the minima. Also we have to check that if it is a stationary point or not. So we can find the first derivative of function, that will be 2x minus 250 divided by x square, and we can equate it to 0, and from here if you see that the value of the x will be, so we can find, right? So that would be 2x cube is equals to 250. That means x is equal to 5, right? Q, that will be 5. Yes, now we can find this. So that means this where we have to check, that is a stationary point, right? That where the function will get changed. So we will find the double derivative of x, that will 2 plus 250 into 2 divided by x cube, right? So now you can check at x is equals to 5, so double derivative is greater than 0. That means this x5 is a point of minima, so you will get the minimum value, and the correct answer for this is B. Okay, now let's look at this question. So the function is given, that is x cube minus 6x square plus 9x plus 25 has, we have to check a maxima at x is equals to 1 and a minima at x is equals to 3. Maxima at x equals to 3, minima at x equals to 1. No maxima, but a minima at x equals. So basically we will have to look for the stationary points, right? From there we will be able to get to know at which point, and by checking the double derivative we will get to know that at which point we will have the maxima or minima. Okay, so first point is, so let's find the first derivative of this function, that will be 3x square minus 12x plus 9. Now we can make it to 0, and from here we can find that x square minus 4x plus 3 is equals to 0. That will be x square minus 3x minus x plus 3 is equals to 0. So x minus 3, so from here we will have x is equals to 1 and x is equals to 3. So these are the stationary points, right? Now we can check for the double derivative, right? So double derivative of this function would be 6x minus 12, right? Now put the point 1 here, you will get f double dash 1 is equal to 6 minus 12, that is minus 6, that is less than 0, and f double dash 3 is equal to 18 minus 12, that is 6. So that is greater than 0. What does it mean? That this point will be point of minima and this point will be point of maxima. So x is equals to 1 is a point of maxima and minimum at x is equals to 3. So A is the correct answer for this. So this question is from 1999 CE. Number of inflection point for the curve y is equals to x plus 2x to the power 4 is 3. So what is this inflection point? So curve where it changes its concavity, right? So let's assume that this curve, so for this reason it is concave up and for this reason it is concave down. So it is changing its concavity at x is equals to 0. So this is the point at, you can say that this is the inflection point for this curve. How we can find this algebraically? So for that we will have to check for the double derivative. So where the double derivative will change, if let me go through this option, then go through this question, you will get it. So first derivative find, so that will be 1 plus 8x to the power cube, and the second derivative will be 24x square, right? Now equate it to 0, so that will give you x is equals to 0. Now take any point, so that one point is the, that may give you the point of inflection point, but for confirmation you will have to check the change of the sign of the double derivative. If this, take any point that is less than 0, so let's take x is equals to -1, and take any point that is greater than 0, so take x is equals to +1, put it in your double derivative, that will again 24, and put it in your double derivative, that will be 24, right? So you see there is no sign change, that means this point is not a inflection point, so we do not have any inflection point for this curve. Okay, now let's look at question that is from 1997 CS. What is the maximum value of the function? We have given this function, that is 2x square minus 2x plus 6 in the interval 0 to 2. Again we will find all the points and we will check that at which point we are getting the maximum value, right? So first point is to find the stationary point, right? So we will take the derivative, so that would be 4x minus 2, right? And we will make it 0, and from here we will find the stationary point, that is 2, right? So what are the points to check? That is in the domain, so check the stream point, and so 2 is there, so these 2 points needs to be checked. So we will put this, so we will find the f0, so that will be 6, and f2, so that will be 8 minus 4 plus 6, right? So that will be 10, right? So point of maxima, what is the maximum value? So maximum value would be 10 at point 2. So this question is from 2004. The function, we have given this function, that is 2x cube minus 3x square minus 36x plus 2 has its maxima at which point? So as usual we can find the first derivative of function, so that will be 6x square minus 6x minus 36, and we can equate it to 0. So from here we will have x square minus x minus 6 is equals to 0. That means x square minus 3x plus 2x minus 6 is equals to 0. That will give you x minus 3 plus 2 into x minus 3 is equals to 0. From here x is equals to 3 comma x is equals to minus 2. Now has its maxima, so we can find the double derivative of function, right? So double derivative of function would be 12x minus 6, right? Now we can put these points into double derivative, and we will check that at which point we are getting less than 0, that is negative. So that point will be minima point, but we have to find the maxima point. Okay, let's do that first. So put x is equals to 3, so f double dash 3, 36 minus 6, so this is greater than 0, f double dash minus 2, so that will be 24 minus 6, so this less than 0. So we have the maxima at which f double dash is less than 0, that is minus 2. So this is the answer. 3 cannot be right. Okay, so this question is from 2005 double E, and we have again similar kind of question. We have given the function, the maximum occurs when x is, so we have to find at what point of x this function has the maxima. So what we can do, we can find the first derivative, so that will be 2x e to the power minus x plus x square minus 1 e to the power minus x. We can equate it to 0. So from here we will have 2x e to the power minus x, that is going to be minus plus x square e to the power minus x. This will get cancelled. That means x square minus 2x is equal to 0. From here we will have x is equals to 0 comma 2. Now we have these stationary point. We have to find the at which maximum occur. So what we will do, we will again find the double derivative of function, so f double dash x. So first let me write the f dash x, so that is 2x e to the power minus x minus x square e to the power minus x. Now the f double dash x will be, let's keep this 2 common, derivative of x is 1 plus, so that will be here minus x e to the power minus x. That is done, minus we will have 2x e to the power minus x minus x square e to the power minus x. Now we can check for x is equals to 0, so f double dash 0, that will be 1 minus 0 minus 0 minus 0, so that is greater than 0, and f double dash 2, that will be 2 e to the power minus 2 minus 2 e to the power minus 2 minus 4 e to the power minus 2 minus 4 e to the power minus 2. So that will get cancelled, right, this one, and here we will have minus, right, so that is going to be less than 0. So what we have been asked, that the maxima occurs at x is equals to 2. So the correct answer for this is A. Okay, let's look at this question. So this question is from IN 2007. For real x, the maximum value of this function e to the power sin x divided by e to the power cos x is. So maximum value of this function we have to find, right? We can take the derivative and we can find the stationary point, and then we can check at which stationary point we are getting the maximum value, then we will put that point to our function, that will give you the maximum value, right? Okay, so also we can go through the options. I think for this question infinity cannot be answer, right, because this is from -1 to 1 and this is also from -1 to 1, so this function is bounded, right, so it will not have the infinite value. Yes. Okay, so now, so I think if we take x is equals to minus pi by 4, right? So e to the power sine x will be 1 divided by root 2. E to the power sine x will be minus 1 divided by root 2, right? And so not this one, but maybe with x is equals to 3 times pi by 4, right? So that here at this value, so this is uh, right, so their sine value would be e to the power 1 by root 2, right? And cos would be minus 1 divided by root 2. So that will give you so this is the answer you will get, right? It will be root 2. Or you can, what we can do, we can find the stationary point, and we can, because this is the maximum, the infinite cannot be option. E is less than e to the power root 2 and 1 is less than e. Okay, so this is the correct answer for this question. Okay, so this question is from 2007 EC. We have given this function, we have to find the maximum value of fx in the closed interval from minus 4 to 4. So we can take the first derivative of our function, that will be 2x minus 1. Then we can equate this it to 0, so that will give you a stationary point. And now let's find the double derivative. So that is 2, that is greater than 0. That means this is the point of minima. So what we have to find is the maximum value. So this cannot be, so we are also going to check at the boundaries, right? So let's find out. So that means maximum value we are going to get at the boundaries, right? Because this point, if we saw that double derivative is greater than 0, so this point is the point of minima. And if we check that f at minus 4, right, so that will be 16 minus plus 4 minus 2, that is 18. And f4 is going to be 16 minus 4 minus 2, so that is 10. So 18 is the correct answer for this. So this question is from 2007 EE. Consider the following function. We have given this function fx is equal to x square minus 4 whole to the power square, where x belongs to some real number. Then the function has only one minima, only two minima, three maxima. Yes. So okay, so let's first of all find the double derivative. So first derivative, that is going to be 2 times x square minus 4 into 2x. Now equate it to 0. So from here we will have points x is equals to 0 and x is equals to minus 2 and x is equals to 2, right? Yes. Now we can check it, right, directly. We can, so these are the stationary point, right? So so the double derivative would be 4 into x square minus 4 plus 4x into 2x, right? So if we put 0, that will give us minus 16 plus 0, so this is less than 0, so this is point of maxima. F double dash minus 2 is 0 and plus 8 into 4, that is 32, so that is greater than 0, so this is point of minima. F double dash 2, that is 0 plus 4, 32, right? So that is also greater than 0, so this is also point of minima. So we have 2 points where we will get the minimum, only two minima. So this question is from ECCS 2008, and what we have to find is the, so question is, a point on the curve is said to be extremum if it is a local minimum or a local maximum. So this is the definition of extrema, right? So the number of distinct extrema for the curve 3x to the power 4, 16x cube plus 24x square plus 37 is, right? So we can find the stationary point, right? So that is f dash x is equals to 12x to the power cube minus 48x to the power square plus 48x, and we can equate it to 0. So from here we will have x into x square minus 4x plus 48 is equals to 0 plus 4, right? So from here we will have x into x minus 2 whole square is equals to 0. So x is equals to 0 comma 2. So these are the two stationary points. Now at what point we will get the maxima where double derivative is less than 0? At what point we will get the minima where double derivative is greater than 0? What if the double derivative is 0, right? So in that case we will have neither maxima nor minimum, so that point will be not a extrema, right? So that is what we have to take care in this question, otherwise you will take this option 2. But let's look that, let's find the first double derivative. So double derivative of this function f is going to be 36x square, right, minus 96x plus 48. Now we can put f double dash 0, so that will give you 48, that is greater than 0, so 0 is point of minima. We can put 2 at this point, so we will have 36 into 4 minus 96 into 2 plus 48. So 36 into 4 is 144 and this is 48, right? So 48 is 192 and this 96 into 2 is 192, that is going to be 0, right? So you see that f double dash 2 is 0, so this is not a extrema point and we have to count the extrema point, right? So that is the only one point, so option B is the correct. Okay, so we have again similar type of question. So we have given this function, that is x square minus 6 plus 9, the maximum value of y obtained when x varies over the interval 2 to 5. So we have given this interval also, right? So in this interval we have to find that what is the maximum value of this function. So we can take the derivative, that is f dash x, first derivative to find the stationary point, so 2x minus 6, we can equate it to 0. From here we will get x is equals to 3. Also we will check at the extreme points, that is in our domain, that is 2, 5. Let's check the double derivative. So double derivative is 2, that is greater than 0. So this point is point of minima. Here we will have point of minima. So now that means we are going to get the maxima point at the boundaries. So at 2 we will have 4 minus 12 plus 9, so that is 1, and f5 we have 25 minus 30 plus 9, so that is 34 minus 30, that is 4. So we have the maximum value, that is 4. So 4 is the correct answer. Okay, so this question is from 2008 EC, and for real value of x, the minimum value of the function e to the power x minus plus e to the power minus x. So we have to find the minimum value of the function. So as usual, we can find the first derivative, that is e to the power x minus e to the power minus x. We can equate it to 0. So from here we will have e to the power x is equals to e to the power minus x. We can take the both side ln. So from here x is equals to 0, right? Okay, so now we can take the double derivative. So that will be e to the power x plus e to the power minus x. Now we can check this point. 0 is 1 plus 1, that is 2, right? So that is greater than 0. So that means this point is the point of minima, right? So what we have to find the, so this is greater than 0, right? So this will be the point of this is the point of minima. For real value of x, the minimum value of the function, this. So we have to find the minimum value, right? So fx is greater than 0. So okay, so this is the point of minima. Okay, so this, at this point we will get the minimum value, right? So that is 2, e to the power 0 plus e2. So the 2 is the correct. Okay, so let's look at this question. So this question is from 2010 EC. If e to the power y is equals to x to the power 1 by x, then y has a maxima at e, minima at e, maxima at e to the power minus 1, minima at. So we have to look for the y, right? And we have given this equation. What we can do? Simply first we can find the y, right? We can take the ln both side, that will give me 1 by x ln x. Now we can find the first derivative, that will be 1 by x into 1 by x, and here we will have 1 divided by x square ln x. Now we can equate it to 0. So that means we will have, because this one will be not there, right? Okay, so okay. So 1 by x is there, and ln x is 1 by x, so that will be 1 by x square. So 1 by x square into 1 minus ln x is equals to 0. So from here what we can say, that 1 minus ln x is equals to 0. So x is equals to e, right? Now we have to check that if this is our maxima or minima point. For that we will have to find the double derivative, right? So double derivative of x with respect to x, so that would be minus 2, so derivative of this one, minus of 2 divided by x to the power cube, and let's take this minus outside, and ln x is 1 by x, so we will have 1 by divided by x cube plus, it will be not plus but it will be minus 2 divided by x cube ln x. Right, now we can put this x to the power, x is equal to e, so that will be e to the power cube minus, so this will be 1, right, when we will put e, and here we will have x cube, or that is e cube, and minus 1, so that will be plus, right, so that will be 3, no, here we will have 1, right. So do you see that overall thing is coming minus 1 divided by e to the power 3, so that is less than 0, so that means at e f double dash is less than 0, that means this e is a maxima point, so we will get maxima at x is equals to e. So we have this question, that is fx is equals to 2x minus x square plus 3. We have to find again maxima minima, at which point maxima we have and at which point we have minima. So f dash x will be x minus, sorry, 2 minus 2x, so from here x is equals to 1, right, so we can check f double dash x is equals to 2, not 2 but minus 2, that is less than 0, so this point is a point of maxima, so we will have point of maxima at x is equals to 1, so this C option is correct. Okay, so this question is from 2012 EC. So the maximum value of this function in the interval 1 to 6 is, so we have to find the maximum value, right, so we can take the find the stationary point, that is fx is equal, f dash x is equals to 3x square minus 18x plus 24, that we can equate to 0, so from here we will get x square minus 6x plus 8 is equals to 0, so from here we will have x is equals to 2 comma 4, right. Now let's check double dash x, so that we can eliminate few of the options, the minima point. So the f double dash x will be 6x minus 18, right, so if we put x is equals to 2, so that is bit 12 minus 18, so that is less than 0, so at the 2 we will have the chance to get the maximum value, and at 4 it is greater than 0, so 4 we can eliminate, right, because we have to find the maximum value. Also we have to take care of this boundaries point, right, so either we are going to get the maximum at f2 or f1 or f6, so whichever will give you the maximum value, that would be the maximum of this function. So f2 will be 8 minus 436 plus 48 plus 5, right, so that would be 56, let me just, yes, that would be 56 plus 5, that is 61, and 61 minus 36, that is 25, right, and if we put f1, then we will have 1 minus 9 plus 24 plus 5, right? So 25 plus 5, 30, that will give you 21. And if we put f6, then we will have 216 minus 36 into 9, that is 324, right? 36 into 9. And here we will have 24 into 6, that would be 144 plus 5. I think at this point, if we subtract, that would be 8, 0, 108, right? And 108 plus 144 plus, so point is that at 6 we will get the maximum value. So this 28 we are getting at 1, this 25 we are getting at 2. So okay, we will have to make the calculation here. So that is how much we have, 216, right? 144 plus 5, so that will give you 6 and 365. अब 365 में से 324, 141, so 41 is the correct answer. Okay, now let's look at next question. Okay, so this question is from 2012 PI. We have given this function, that is x cube plus 1. At x is equal to 0, we have to check that if it is maximum, minimum, right? So this is well known function, that is x to the power q, right? And we have plus 1, so when x is 0, it is plus 1. So we will have curve that is concave up for this part and concave down for this part, right? So we will have at x is equal to 0, so this is the line of x is equal to 0, where concavity is getting changed, right? So we will have the inflection point at x is equal to 0. The correct answer for this is D, right? We cannot have the x is equal to 0, because you see that for x is equal to infinity, that function will be infinity, and x is equal to minus infinity, so maximum minimum point is gone. And it, or also you can check by doing the calculation. For that you will have to find the f double dash x, and so if you find f double dash and equate it to 0, so from there you will get x is equal to 0, right? And now that x is equal to 0, you will check any point, you will pick any point that is x is less than 0, so you will find that you will get the negative. And for any point in f double dash x, you will check that you will get overall pointed that around, for greater than x and for less than x, you are going to get the change in sign, so that you can call the point of inflation. Okay, now let's look at okay, so let's look at this one. So this is from ME 2012. A political party orders an arc for an entrance to the ground in which the annual convention is being held. The profile of the arc follows the equation, that is the important, that y is equal to 2x minus 0.1 x square, where y is the height of the arc in meter. The maximum possible height of the arc is, right? So it's a maximum minimum question. What we can do, we have given that y is equals to 2x minus 0.1 x square, and we have to find the maximum possible height of the arc. So we can take the derivative, so that would be 2 minus 0.2 x, and from here we will have, we can equate it to 0, that then we will have x, that is a stationary point, that is 10, right? Now find double derivative, that is going to be 0.2, so that is less than 0, so that means this point x is equals to 10 is the point of maxima. We can put this into our function, so that would be 2 into 10 minus 0.1 into 100, so 20 minus 10, so 10 is the maximum possible height of the arc. Okay, so this question is from EC 2014. For t greater than 0 less than infinity, the maximum value of the function e to the power minus t minus 2 e to the power minus 2t occurs at. So at what value of t the maximum value will occur? So we can take the first derivative of the function, that will give you minus e to the power minus t plus 4 e to the power minus 2t. You can equate it to 0, so from here you will get the stationary point, so you can take it e to the power minus t common. From here you will have e to the power minus t, that is equal to 0. So from here you will get a point which is so I think I will have to do it. So 1 is equals to 4 e to the power minus t, e to the minus t is equals to 1 by 4. You can take both side ln, so that will give you t is equals to minus ln 1 divided by 4, or you can write it as ln 4, right? So now we have to check if this, at this point, f double dash x or f double dash t. So let's check it if it is a maxima point. So that will be e to the power minus t minus 8 e to the power minus 2t, right? So now if you put the value, right, so e to the power minus ln 4 or we can write it as 1 by 4 and we can make it plus, and we can write it 1 by 4 and make it plus. So that would be 1 by 4 minus 8 into 1 by 16. So that would be less than 0, right? 1 by 4 minus 1 by 2, that will be minus 1 by 4, right? So that confirms that this point is a point of maxima, right? So the correct answer for this is log e to the power 4. Okay, so let's look at this question. So this question is from 2014 EC. So the maximum value of the function, this where x is greater than minus 1. Okay, so at which point of x we will have the maximum value. So we can find f dash x, that will be 1 divided by 1 plus x minus 1. We can equate it to 0, so 1 divided by 1 plus x is equals to 1, right? So that means 1 plus x is equals to 1, x is equals to 0. That is the stationary point. we can find f double dash x, right? So that would be 1 divided by 1 plus x square, right? And minus will be there, and if we put then x is equals to f double dash 0, then that will be less than 0. So this point is point of maxima. We can put f0, so that would be ln1 minus 0. So ln1 is 0 minus 0, that is 0. So the maximum value of the function occurs at x is equal to 0. Okay, we have to find at which point, so at x equals to 0. Okay, let's look at this question. So this question is from 2014 EC, right? So we have to find the maximum value of the given function within the domain x is equals to 0 to 3. So we can take the double derivative of this function, that would be, for single derivative, that would be 6x square minus 18x plus 12. We can equate it to 0. So from here we will have x square minus 3x plus 4 is equals to 0. So x is going to be not 4 but here 2, right? 1 comma 2, right? So x will be 1 2. Now let's also check the double derivative, and we can eliminate few points where we will getting minimum, right? So f double dash x would be 12x minus 18, right? Now if we put 1 here, and then it will be less than 0. So 1 is the possible that here we can get the maximum value. Now if we put 2, then that would be greater than 0. So that would be the minima point, we can neglect it. And apart from that, we have to also check at the boundaries, that is 1 0 and 3. So we want to have the maximum value, so check at this point, and whatever the maximum you will get, that will be the maximum. So 1 f of 1 will be 2 minus 9 plus 12 minus 3, right? So that is 14 minus 12, that is 2. And f of 0 would be minus 3, right? And f of 3 will be 54 minus 81 plus 36 minus 3. So 81 or plus 3, that would be minus 84, and that will be 90, right? So 90 minus 84 is 6. So this is the maximum value that we are getting out of this, right? So this max will be 6. So the maximum value of this function in the interval is 6. So 6 is the answer for this question. Okay, so this question is from EE 2040. Let me write it down. So if we have given this fx is equals to x e to the power minus x, the maximum value of the function in the interval 0 to infinity. So we have to find the maximum value in the interval 0 to infinity. We have given option A, that is e to the power minus 1, B e, and C 1 minus e to the power minus 1, and D 1 plus e to the power minus 1, right? So we can take the first derivative, that would be minus x e to the power minus x plus e to the power minus x, and then we can equate it to 0. So from here we will have e to the power minus x common, minus x plus 1 is equals to 0. So from here we will have x is equals to 1, and we can find the f double dash x, that will be x e to the power minus x plus, but here we will have minus e to the power minus x, right? First we have taken the derivative of e to the power x, then we have taken the derivative of x minus e to the power minus x, right? So we will have x e to the power minus x minus 2 e to the power minus x. Now if we put x is equals to 1, so that would be e to the power minus 1 minus 2 e to the power minus 1. So it is nothing but it is not here, 2 e to the power minus 1. So it is minus e to the power minus 1, that is less than 0, right? So we are getting derivative, double derivative at x is equals to 1 less than 0. So this point is point of maxima, so we can put it in our function. So x is equals to 1 is e to the power minus 1. So A is the correct answer. Okay, so this question is from 2014. Minimum value of the real valued function. This, so it's a real valued function. Fx is equals to x minus 1 to the power 2 by 3 occurs at x is equals to. So you see that this fx is equals to x minus 1 to the power 2 by 3, right? We can find the stationary point, but in this case we will not have any stationary point. Let's look at this. So that is going to be x minus 1, 2 by 3 will be there, and here we will have 2 by 3 minus 1, that is minus 1 by 3. Then we can equate it to 0, so we will have 2 divided by 3 into x minus 1 equals to 0. So for none of the value we can get this 0, for none of the real value, right? So this fx is equals to x minus 1 to the power 2 by 3, right? And since it's a real valued function, then this value should be greater than equals to 1, right? So the domain of x is greater than equals to 1, right? So minimum value we will have at x is equals to 1, that is 0. So for this question, 0 is the correct answer. Okay, so we have been asked here that minimum of the occurs at, so at which value it will be occurring. So it will occur at x is equals to 1. So 1 is the correct answer. 0 is the minimum value, but at which point? So x is equals to 1. Okay, now let's take one more question. That is from EE 2014. So we have the function that is fx is equals to x cube minus 3x square minus 24x plus 100 in minus 3. So 3. So what we have to find? The minimum value of the function. The minimum value of function in this range, in this domain. So a is equals to 20, b is equal 28, c 16, d 32. Let me know what's the answer.